Hello everyone, my name is Shiv Patel. My SAP ID is 56 batch B4. I am from third year of electronics. In this video, I am going to design a V2I converter for ground load and floating load potential using simulation tool LT-SPICE. Before jumping to the simulation tool LT-SPICE, let me give you a basic idea of floating load V2I converter. So this is the circuit for the floating load V2I converter. The floating load basically means that the load is not connected to the ground. Instead, it is provided to the feedback loop of the op-amp. This is the calculation for the floating load V2I converter. So output current, which is IL, is equal to V in upon R, which means that it is independent of load resistor RL. So let's check whether it is dependent or independent. Let's see whether this hypothesis is right or wrong by using LT-SPICE. I have already designed the circuit for the V2I converter for floating load potential. So input resistor is 250 ohms. Let us take output as 250 ohms. The input voltage is 1 volt. So let's see the output current. So the output current we got is almost 4 milliamperes. So let's change the feedback resistor and see whether it remains the same as per the calculated equation. Let's take 10 kilo ohms as the feedback resistance. So it should be 4 milliamperes as per the calculated formula. Let's check whether it's same or not. Okay, so we got 1.367 milliamperes, which means that it is not independent of load resistor RL. So the hypothesis is proven wrong. Let's check for another value of input voltage. Let's take 5 volt, 5 volt, 250 ohms, run. So we are getting 20 milliamperes approximately. Now let's change the feedback resistance as 10k. We should get the same as per the calculate formula, but we got a different value, which means that it is dependent of RL. The load current is dependent on RL. So the hypothesis is proven wrong. Now let's move to the ground load V2I converter. So this is the circuit diagram for ground load V2I converter. As you can see, all the resistance value is equal and the RL is directly connected to the ground. This is the calculations, and here the output current is equal to V in upon R, which means that it is independent of RL. So let's check this hypothesis using simulation software LT-SPICE. I have already designed the circuit diagram for V2I converter for ground load potential. The resistance value are same and RL is equal to 120 ohms. So let's run. Let's see the value across load resistor. As you can see, the IL value is equal to 4 milliamperes. So to prove, to check the hypothesis whether it's right or wrong, let's change the value of RL so that we can see whether it is dependent or independent. So first remove this, let it be. So let's change it to 2 kilo ohms. Now let's run. It should be 4 milliamps, but let's see. So it is 2.539 milliamperes, which means that it is dependent on RL. So our hypothesis is proven wrong. So let us check for one more input voltage value. Let's take 5 volt. Let's take 120 ohms again as RL. Now let's see the value. So we are getting 20 mini amperes for 5 volt input and 120 RL value. Now let's change the RL value to 2K. Now let's run the code. So we are getting 3.98 instead of 20, which means that it is dependent on RL, so hypothesis is proven wrong again. So that's all for the ground load potential. This is the floating load observation table. As you can see, for the load resistor as 250 ohms, the IL value matches for theoretical and floating, but when we change the RL value, this value does not match. That is theoretical and float observed. And for the grounded load potential for RL is equal to 120 ohms, the IL grounded and IL theoretical value is almost same, but when we change the load resistor, the values does not come the same. As you can see, for 2 kilo ohms they are not same, and for 10 kilo ohms they are too far away from each other. The observed is in microampere and theoretical is milliamperes. Now we will see the functional diagram of XTR111. So XTR111 is a precision V to I converter capable of producing currents up to 36 milliamperes. As you can see in the circuit diagram, no resistor are used, only the R set is used to form the relation between I out and R set. So we have also used P-channel MOSFET for easy power dissipation. In the industrial environment, this arrangement is very useful for suppressing the interferenceness of the output impedance. So basically XTR11 can be used as universal voltage control current source, as load current does not depend on load resistor. So this was all in this video. Thank you for watching.